thanks everyone for joining. I'm very excited today to be speaking with Malte Pietsch to talk about the pitfalls and how to build with LLMs. A quick introduction of Malte. So he is the co-founder and CTO of Deepset.ai, where he's building Haystack and Deepset Cloud to enable developers to use NLP effectively. Previously, before Deepset.ai, Malte has been developing NLP applications for the last 8 years. And so, yeah, he's definitely very well experienced and placed to run our workshop today. So I think given the nature, we are going to do something slightly different. Malte, could you give us a quick introduction of Deepset? What your product does? Maybe we spend 5 to 10 minutes just on that, and then we can kick off with our regular topics.
Yeah, cool. Sounds perfect. And yeah, thanks for the intro. Thanks for having me here today. So let me then maybe start sharing my screen. So you should hopefully see it now in full screen. Is it working?
Yes, we see it now.
All right, perfect. Yeah, so hey everyone again, and thanks for having me. Yeah, I really just thought, okay, for kicking this off today, before we dive into discussions, open questions, things that yeah, you might wonder when talking about LLMs. I thought it might be helpful to just share a bit of our observations of perspectives, put some things into kind of context from our work. I won't talk too much about our product and what we're doing, but rather, okay, what did we learn from the interactions with our customers? What kind of challenges did we see when people try to move LLMs into production? And as this topic is, if you see behind a bit the noise, it can be, I think, quite difficult to see the things underneath. I thought it might be helpful to have a quick intro, kind of 10 minutes, and then we dive into open discussion. So to give you a bit of an idea about my daily work, Lex already mentioned I'm working at Deepset, responsible there for product and engineering. At Deepset, we build 2 products. One is an open source framework called Haystack, which helps single developers mainly to compose LLM pipelines and agents from different underlying components like models, vector DBs, other processing steps that you might need, like file converters, and so on and so forth. And then we have Deepset Cloud, our commercial product, which is an end-to-end platform that really enables teams to build, deploy, and monitor LLM applications. So a bit wider, really from prototyping to production to monitoring, all that we cover there, and mainly for teams who then really collaborate. So when we talk about LLMs here today, I think, yeah, we're all, I guess, aware that they already unlocked many exciting new use cases. I think they are really the future for NLP and big parts of AI. Still, I feel there is sometimes these 2 realities out there. There's this crazy buzzword when I open up my Twitter feed, where everything seems possible, super easy to build shiny demos. And then there's the kind of industry reality, enterprise reality, when I talk to engineers, to PMs, who want to try actually to get from a first demo to something running in production. So today, this short talk, I want to focus more on the second world. What are these challenges when moving to production? And basically, over the last 5 years now, we worked with more than 50 enterprise customers, thousands of open source users on building NLP into their products. Since last year, I would say this then mainly involved LLMs. And by today, I would say we don't see any new customer who at least wants to try it out, compare it to maybe more traditional models. So it definitely dominates our daily work. Yeah, so I want to share some of our learnings, some of the challenges we saw, and how to maybe overcome them, and then happy to go into the more detailed discussion. So I will divide this session here, or this quick talk, into 3 parts. First, giving a bit of an overview about typical challenges. Then one key technique that I think everyone should be aware of these days. And then third, a very quick demo how these things can look in reality. So let's get started with these, let's say most common challenges that we observed. Number one, most of the real high-value use cases we see in companies include typically some internal company data. So there's data that is not available on the public internet. It's often from a special domain, could be aircraft maintenance documents, could be contracts, could be financial reports. And the typical question that comes then is, how can we tune the model to our data? How can we teach it about this internal knowledge that it hasn't seen before? The second is then quite closely related to this first one. When our use case relies on this internal data, how can we make sure that we stay basically in control? Must be safe, must be secure. Maybe company policies or regulations don't allow sharing that with third parties. How can we cope with that for that? Third one, make it scale. Of course, we move to production. This not only means like in technical terms of latency and throughput, but also often then in terms of costs and model performance. It's really all about finding the right balance there. So I think there's no holy grail. It really depends on the use case, on the business. But yeah, we should think holistically about it, and it's not straightforward. Number 4, basically next big question typically is then around quality and quality assurance once you go in production. I think we all saw these models hallucinating by now, simply making up answers. And if your application that you want to bring to production is exposed to really customers, it's not just an internal project, this could be an extremely damaging to your brand. And this is what we get a lot, like people like the demos, but they're really hesitant and careful of what they expose to end users, because they say, oh, like if this is something making up, it will be a PR nightmare. So how do you know that this model is good enough, safe enough to deploy? How can you assess this quality and basically monitor it then also once you're in production? And last but not least, think product. So many people forget, I think, that LLMs are just a technology. And like with every technology, it will only create user value if you embed it in your product in the right way. So for LLMs, this is really no exception. And I would say just adding a chat interface next to your product won't automatically create user value. So you really need to have proper product management, design, explore, validate your integration, and see what drives this value for your particular product. I could probably talk about each of these challenges for hours, and happy to dive later maybe a discussion into other of those. Today, maybe just quickly expanding on these 2. And let's start with this topic around hallucinations. What is actually an hallucination and why does it happen? So a very quick refresher here at this point. And yeah, let's just ask GPT-4 here about the number of Model 3 vehicles that Tesla produced in the first quarter of 2018. And from the first look, this answer that we get here sounds convincing. It gives us a number. It even mentions a source, the shareholder letter of Tesla. Nice. Could be right. The only problem is if you open this shareholder letter now, you find that this is unfortunately the wrong number. Instead, kind of 9,000 vehicles of that type were only produced. And this is really now a hallucination that can be problematic. Imagine you're financial analyst using this LLM at work, you maybe base some decision on those numbers. That can be pretty bad. And particularly because it's hard to spot that hallucination. It's not an obvious one where the model makes up some funny stuff. but it's really quite hidden for the end user. So why do models actually hallucinate? Broadly said, there are, I think, 3 triggers. In our case here, it's probably the third one, and one of the, I would say, hardest to actually catch. The model has seen some kind of related information at training time. It probably has seen this kind of shareholder letter, but then mixes up the actual answer. And these are very hard to spot for humans, but also for many automatic methods. When we look at token probabilities, for example, of these generated answers, these are the ones that are hard to actually get. So now that we refresh quickly what hallucinations are, how can we reduce them? And also let's, in combination, tackle the second challenge. How can we teach LLMs about our own internal company data? Turns out that there's one key method that can actually help with both of these, and this is called retrieval augmentation. And let me just quickly explain you this idea. So plain kind of prompting, plain QA with an LLM looks like this. You have a question, you convert it to a prompt, maybe some extra instructions, you send it to an LLM, and then you get your answer. Very simple. Now with retrieval augmented generation, we still have here our question on the left. We still have our prompt that gets fed then to the LLM. However, what we do now is to insert some more information in our prompt. So basically what you see in green here, we want to provide the LLM with some useful information that helps the model to answer our question in a really truthful way. In our example, this could be here the shareholder letter from Tesla, or other information about this number that we want to get. Of course, we want to get some, or use some automatic way of searching and inserting these truly relevant documents in here. So what we do is now connecting our pipeline with a so-called retriever, like another model that searches for these kind of documents, these pieces that we want to insert in an external database, it could be a vector database, and then put these documents into our prompt. And when we do that, the nice thing is that we kind of solve or tackle multiple problems at once. First of all, we reduce hallucinations because we ground the answers on these documents, on this really fresh information. Second, we can also teach the LM now about information that it hasn't seen before. So maybe some very special company data, internal data that is not on the internet. And last but not least, it helps with explainability. So now as a user, remember this example with the Tesla, I could easily go into the source and look in like the source document where this comes from and verify, okay, is that really true now or not? There is no path to that. So with that, let's move quickly to a demo to see a few things in action, and then go to an open discussion. In the demo that I'm now kind of sharing, I want to illustrate two things. One is this difference between a plain GPT pipeline, so just plain prompting, and retrieval augmentation. And the second thing, we talked about like quality assurance as one major challenge. This happens at different stages in the application lifecycle, and we will see that like a few pieces here in the demo as well. One analogy that I like here is traditional software development as well, where you do some things for quality at development time, maybe like debugging, like a local dev, like a single dev, trying something out, making sure that the function works. Some things you want to run more systematically, more automatically, maybe in a CI at release time. And some other things you only run then at production. You monitor, maybe you have some product metrics, some alerts, and the same holds for LLM applications. So with that, let's go. Hope you see now a product screen. I'm sharing that. And what you should see here is now a tab from a module from Deepset Cloud, where I uploaded some more realistic data now on ESG reports. So these are reports from big institutions around their activities in environment, social governance, and a lot of investors use that to understand if they can invest in these companies, if they are compliant with maybe their policies of the fund. And yeah, this means a lot of manual work for financial analysts, because these reports, we can open maybe one here, they're often like between 20 to 200 pages long. They include a lot of text, but then also like some graphics, some tables, and it's often hard to really get then this single piece of information that you might be interested in.
Malte, can I
yeah
interrupt you there? Quick question. So what happens if the PDF is not readable? Like it's a picture. Yeah. And then my second question is, because I'm guessing this you're gonna what's happening is you're then chunking like bits of data like into the model, right? Like, is there any ideal settings for chunking to improve or to reduce hallucination?
Yep. So this is basically what I mentioned earlier with like components outside of the pure model that you need to really build a working application. One is these file converters. So we have some in Haystack for PDFs. We have also done some that do OCR. Basically, if the PDF is the picture, so kind of translating from a picture to actual text. And yeah, depending basically on your file format, what you have, you pick then the right converter in your pipeline. The second part is then about kind of chunking, and this is then typically something done by a so-called preprocessor, so another node in our pipelines. We can have a look in a second. And there, it's really important that you split it up. So even now with some models can take quite long context windows. Like Claude from Anthropic can take 100K tokens. So we could probably just move the whole report in there. But this is like not cost efficient. So all these providers bill by number of tokens. So if you have then, I don't know, thousands of requests in production, this can be very, very expensive. And the second thing with performance, it also doesn't help. Like the attention that we have so far in these models is not working very well on large context windows. So the more noise you put in, irrelevant information you put in, the worse your predictions get. So what you can do is this kind of slicing, like chunking, and let's maybe go into these pipelines that we have here. So here I have now one a plain GPT pipeline, and then this retrieval augmented one. And let me make this one big. What you see here is basically we have here these file converters that I mentioned, then a preprocessor, and if we look at these parameters, we see here that we split by, in this case, a unit word. There are also settings that you can split by sentences or paragraphs, that you don't cut it in between. We definitely want to respect sentence boundaries, so we don't just cut it somewhere in the middle. And then we have a sliding window. So we always overlap these sections. 30 is, I think, a default good choice here. And something like around 250 words is something that, like for like length of such a passage, that worked well for us in many cases. So hope that answers your question. Thanks.
No, it does. Thank you.
Cool. So then, while we're here, let's maybe quickly talk also at the look at the query pipeline. So this is basically what we saw on the slides. The query comes in. We have here our retriever that fetches now relevant chunks of these PDFs from our vector DB, and then we have a prompt node where this basically gets inserted into the prompt and then sent to an LLM. And all of that is then usually versioned and defined in a YAML or Python format. And maybe the only kind of relevant info to highlight here is how many of these documents, of these chunks, do we now insert in our prompt. In this case, it's only 2. So out of all these PDF documents split in I think a couple of thousands of passages here. We want to just pick 2 and move them in. And what we can do now is have a quick look how these pipelines compare. So this is just plain GPT, no retrieval at all. And if we ask something like, did gender representation improve at AIG, one of these companies, it's basically now just sending it to OpenAI in the background, to a GPT model, and then we get an answer. So in this case, it says, difficult to answer without more context. They do something, but it's not very grounded. And I tried that with like a few times with different temperature to get different answers. And in many cases, it's hallucinating what kind of initiatives are actually mentioned here. Now let's do the same thing with our retrieval pipeline. And there we now see, okay, some more like actual information, like numbers. We see how it increased from 2020 to 2021 by 0.6 percentage points, and 55% of the workforce are female. And we can go now into this document, this PDF here again, or into these chunks, like these, so to split it, and can easily see, okay, here there is actually some information kind of highlighting what we're looking for, or like we can verify that this is true as a test. With respect to time, I think don't show too much anymore, maybe just one thing. So if you want to go to this, let's say, CI stage or more systematic experiments, there's definitely something I would recommend around experiments. So think of building a small evaluation data set that you can kind of run again and again against different model configurations or pipeline configurations. And usually like you start from some kind of baseline, just the basic performance, look for one metric ideally, and then start with some variations. Maybe you do some prompt engineering, try there a few things out, see how this affects the score, maybe change a bit how many documents you want to insert to find there like a good balance. Second part, decide looking at the single score. I would always recommend looking into really examples. So in this eval set, okay, what does the model actually produce? Are these answers, do they make sense? Are there maybe some patterns? Does the model maybe only get years wrong or numbers wrong? Because then you can kind of have an informed next step, maybe change the prompt, change the retriever to really improve your pipeline. And with that, I would say I cut it here. Let's take the rest of the time for more discussion.
Right. And so to me, the most pressing question today is, how do you build, these workflows so that you can scale the number of searches and queries at a more cost-effective way?
You mean the development workflows?
Yeah, how do you set up these LLMs, or whether if it's, like you mentioned, you only retrieve 2 documents, so that also of course reduces your token window. But then is there any other way? So what I've seen is people also break your goals into multiple steps. Some people also maybe pre-train another model, which then feeds into GPT, which is more powerful. What are some of the best practices that you've seen that people have done to reduce the costs of inference?
I mean, this is definitely costs are a problem with these LLMs if you have large scale production cases. I mean, some of the things is they usually bill by number of requests and tokens, right? So what you ultimately try to minimize is the number of requests, keeping them low and keeping them rather short. So One technique I would say, definitely don't go for this 100K context window and just dump everything in there. But think of, like, what can you take out? Like, how can you make this prompt shorter? One way, related to what we saw now, is retrieval augmentation. So where you say, okay, I rather have only very few short snippets that I input there, than, I don't know, full PDFs, full documents. Like, really have an efficient retriever that selects the relevant parts, and this can reduce costs quite a lot. The other part then is of course, like, if you have like a lot of requests, is there maybe a way to reduce that number? I saw people starting to cache requests before they maybe send the query to the LLM provider. Look for similarity with previous previous queries that came in. Can be quite long-living cache, or maybe some even persistent, to basically reduce the number of calls there. And probably the third other big theme I would say is like, what I recommend usually is starting with these big models, because they're very good for prototyping. You get going very fast, you get good results. You get an idea how that might fit into your product. You can get user feedback, see, okay, is that going anywhere? But if you're there at the stage when you want to move to production, and it's really about a case where you have, I don't know, millions of requests coming in, then it's also worth thinking again, okay, do we really need this large model? And do we need OpenAI, for example, in that case? There's definitely ways to kind of reduce the size then, and maybe go for smaller specialized models. Depends then again a lot on the use case, how generic must the model be. But if your use case is maybe a bit more specialized, has clear barriers, then often kind of training or fine-tuning a smaller model works. And then you of course have options to self-host these models. I did the other day some, because we had also internally we need some information on, okay, how do actually the different LLM providers bill, like what's their cost structure, and how does it compare to self-hosting some of those. And it's very different numbers. You just pull them out. I think I did that for 1 million requests. Was my kind of ballpark figure, and the LLM providers really vary between 2K for this 1 million request to, I think, 40, 60K.
Wow.
So yeah, even there you see big differences. And then self-hosting is cheaper, right? Like, so this is then maybe 1K or below. Yeah, so there you have also a lot of choices.
Thanks for that. And one more question before I open the floor to any to the audience is right now the LLMs, they don't remember, right? Like the previous prompts, and it's limited by the size of the context window. Is there any way to try to hack this so that, you know, like whatever you are typing, like the model actually remembers what you typed?
Yeah. So yeah, it's finally we launched something in that area in Haystack, I think 3 weeks ago, we released it, called Conversational Agent. And there conversations is often where you want to remember the previous history, right? And of course, the naive method is to just kind of append, put the previous conversation into the prompt again. Then, as you're saying, you're limited by the context window length. But what you can do instead is, like, again, externalizing this memory, like putting this somewhere out, and then at query time, trying to get the relevant pieces in. So it might mean for, I don't know, if your conversation is very long, take an example, you maybe don't need all of these history, right? You don't need, I don't know, the last 3 hours of conversation. But what probably matters is like recency, like the last few interactions. And then depending on the content, maybe a few pieces from earlier, like earlier hours. So what you can do again is kind of retrieval, finding the relevant pieces, only putting that into your prompt, and therefore kind of remembering previous states of the conversation.
Got it. Okay. Thank you for that. I'll now open the floor to the audience. So feel free to ask Malte any questions. Any takers? Otherwise, I've got tons of questions to ask.
Hi.
Oh no, go for it.
No, please.
Sure. So I had a question just in regards to the retrievers. So let's say you're using a vector database to store your embeddings of the data, and you're using a distance function to retrieve the relevant subset. How can you ensure that the results of that are consistent and accurate? Like, how can you make sure you're always pulling out the relevant, the really actually relevant parts of the data from that vector database?
Yeah, so we are then, if I got your question right, like again, talking about evaluation of this. So when we talk about these LLM pipelines, we have different things that we're interested in. One is the final performance, so really are the answers that we generate correct. But then for what you are now saying, I think is we also are interested in how well does this retriever work? Can we rely on the information being pulled out there that isn't really correct? Because if that's not correct, the LLM has basically no chance to generate the correct answer. So yeah, what you can do there is basically having a small eval set, like examples basically, where you not only say this is the expected answer, but also, okay, here are the documents where, like, what I would expect to like the retriever finds and puts in there. And then you have this kind of classical retriever metrics. So this is, I think, like 20 years now of research field that you can look at, the map scores, or yeah, I would say map and precision recall, probably the most important ones. And that gives you then some guidance also where to optimize your pipeline. Should you rather experiment with the prompt because retriever is working well, but generated answer is not right, or should you focus on actually on the retriever? Does that make sense?
Yeah, I think so. A couple of things for me to dive into there, I suppose. But yeah, that makes sense.
And then those prompts, you're talking about few shot prompting, I'm guessing. That's what you were referring to?
Sorry, you're asking me with regards to my question?
No, like Malte, like with regards to your answer, yeah.
Like the prompt, like the instruction in general. So
yeah.
Doesn't have to be few shot, like where you really have then examples. But in our case, it could be also a lot on really instruction. Like, for example, we found, I mean, that's like, I think there's now kind of witchcraft of prompt engineering, which I'm not sure how long it will persist, but I think in the current stage, you can still get something out of telling the model that it's a certain expert, like, I don't know, be a professor, be a financial analyst, be whatever, a poet, and it guides basically the model into a certain solution space. We can also try to, if we talk about retrieval augmentation, to make the model like that it's really grounding the answers on the documents. It doesn't help just to put them in there, but you also need to tell them, okay, just look in there, and kind of calibrate that the model says, I don't know, there's not enough information if it's not really in these documents. So that's what I would say, prompt engineering. But what we typically see more actually is that to get more if you optimize this retriever. That's
interesting. Any other questions from the audience?
Yeah, hi.
Hi.
So what if the retrieval is directly from a database? So what if it's like mostly numerical data instead of text?
So can you repeat that?
What if the data is mostly numerical, directly from a database instead of text?
So it comes some kind of relational database, SQL database.
Yeah.
So I mean, this is basically one area, like text to SQL is the common term there, where you can try to put the schema into the prompt and let the LLM generate like a SQL query that then pulls out this information, if it's really like a bigger relational database. What the other part that we see is if it's like rather, I don't know, a certain table in a database where you already know, okay, this is where I should look at, then you can rather treat it as table question answering. Could be also an Excel sheet, for example, a CSV, something like this. Then you probably don't need to generate a SQL query, but it's rather than getting this table the right format again into a prompt, maybe reducing the rows to the relevant parts, and then letting the LLM generate the answer from there.
I'm sorry, can you repeat the second solution that you mentioned after this SQL part? I didn't get that.
So if you don't have a like complex relational database with multiple tables, but if it's rather a single table or maybe a CSV, like a flat kind of structure, then I wouldn't recommend generating a whole SQL query, but rather treat it as a so-called table question answering case. And there are certain smaller specialized models for this case, but also with larger like LLMs now, larger language models, it can actually work that you just take, let's say, the CSV, put that into the prompt, and then instruct the model, hey, here's this table, answer this and this and this question. Depending on the table format, you can then do a lot of things. One is like reducing it. If you, I don't know, maybe you have a query and you already know this is, I don't know, for a certain customer. Maybe you can do something to reduce, let's say, the rows in the table to only relevant ones for that customer. So as a kind of a pre-processing step. The other part is you could add extra information on the schema. So if you have, let's say, columns, not only with the column names, but you could explain what these column names actually are. So to give more context to the LLM. But there it would be mainly about getting this table, formatting it in the right way, trimming it down, putting it into a prompt.
Yeah, good. Thanks.
Yeah, on the same question, I actually wanted to ask something else. So how do you prevent syntactical hallucinations for these cases?
Yeah, this is difficult. So can you give an example of maybe you have some hallucinations that you experience yourself with syntactical?
Mainly something related to having, I would say, because what happens is sometimes for very complex queries, the network hallucinates, I would say, when there are multiple tables that are being queried. So something like that.
Okay, so you're talking about this rather first case where you really have a big relational database and you want to generate a SQL query?
I mean, it's more to do that the query itself is very complex. I mean, the relational database could be small, but
but you want to generate a query and then execute that query, basically.
Yeah. How would you reduce hallucination?
So I mean, I didn't dive into that area myself in details, to be honest. So I haven't worked on it. What I saw from a distance from some of our customers and solution engineers working in that area. So I think one thing you can try is self-reflection. So basically, let's say you have a prompt and you feed it to the LLM. And when we talked about retrieval augmentation, it was everything about optimizing this prompt that gets fed to the LLM. Of course, you can do also something after the LLM generate the answer. And let's say in your case, you generated a SQL query from that LLM. you could add a reflection step, basically asking the LLM again, hey, here's this query. Is that a syntactically correct SQL query? Could I execute this? And if not, correct it. So this is one way that I could see. And the other is probably like giving more examples, like the introduction of few shot examples that you insert in your prompt, more examples of, okay, these queries didn't work, or this is, I don't know, something to like failure modes maybe that you saw. Last resort would be fine-tuning. So from the OpenAI endpoints, like the services, there's a fine-tuning endpoint service. But this is very expensive, to be honest. Like there would be very careful. Not so much the training part, but then the inference part. So if you have really then thousands of requests or millions of requests, this can be very expensive.
Right. Great insights. Thank you so much. Yeah.
I have a question. I'm curious, you mentioned that the range per million requests is quite large in cost. So how do you make that decision, of, it sounds like less than 1K if you self-host versus up to 60K in the other one? I mean, that's such a large range that it seems like you have to have a pretty compelling case to move up. Can you talk a little bit more about that?
Yes, sure. So maybe if times I can also quickly pull out the numbers here. Share my screen here maybe again. Okay, I think this should be this one here. You see an Excel spreadsheet? Like Google spreadsheet?
Yeah.
So that was this kind of calculation that I did the other day. And basically see here different models, and here down here the costs. Zoom in. And yeah, so we have here basically this range of, for 1 million requests of GPT 3.5 Turbo, it's like 2K. This fine-tuned variant is already 120K. GPT-4 with the smaller context window, this 8K is 45. So yeah, these are kind of the really big differences and big spectrum that you can see. And Google is actually quite, rather on the cheap side of things. So what I got from them is that they, I think, want to stay there, and so it could be an interesting alternative. When we talk about self-hosted, so I think right now Falcon is probably the I would say most relevant one to try out, because it also has a quite permissive license. And there the bigger instance here I see is around about 1K. So it's not like bulletproof here benchmarks, but like kind of back of envelope calculation. And now to your question, how do you decide? Yeah, it's unfortunately it's not an easy decision, but it's this trade-off, right, for a use case. What kind of performance of the model do you need to kind of create user value? And then how much is this worth, right? So that's why I would recommend that usually starting with one of these bigger ones, but also there maybe be pragmatic, and I would probably rather go for such a model and not for GPT-4 if you don't really need it. And then if you have something working, start compare with, I don't know, a PAL model, maybe with something self-hosted. So I would say still also these Falcon models are great, and we made like amazing advancements in the last month in open source. Still they are not like GPT-4 level. Probably also not yet.
And I imagine folks have been using GPT-4 maybe to train some of the smaller models itself to get some sort of approximation for a particular vertical, just to bring the cost down and target it to that.
Yes, this also happens, that you can kind of create training examples for those models and then fine tune them further. the problem or the challenge there is that you have to regenerate many relevant ones. Otherwise, you are overfitting of these examples. So
Makes sense.
like also with these benchmarks out there, I would be a bit careful. If you see, I don't know, Llama outperforming some GPT models or being very close, because if you would train from these artificial labels or examples, there's a big risk of overfitting on those and not
Makes
learning
sense.
the actual knowledge or information stored in the models.
Makes sense. Thank you so much for that answer.
Great. That was really helpful. Any other questions from the audience? Otherwise, I have one regarding fine tuning. So what's the best approach today to fine tune a particular model? And given that, you know, like if the model upgrades from GPT 3.5 to 4, you have to fine tune, you know, the GPT 4 again. Like, is there any other way to go? I guess the other way is that you just be better with prompt engineering. Like I'm curious to hear your thoughts here.
Yeah, so I would probably think of it in kind of sequences or things that you start with, and only if that doesn't work, then you go maybe to the next level. So yeah, typically I would always start with prompt engineering, and again, retrieval augmentation can also help to fine tune, like really finding the right documents, putting them in, basically boosting performance until you're happy or like satisfied, let's say, it's okay. This is really about just model performance and what does that create user value before going into any cost optimization. So what I see as a big trap, not only with LLMs, but general NLP projects, computer vision projects, is that you optimize too long before showing it to end users. So what I really recommend and what we try to put in all our products is build a fast prototype. And I would say with a large model, try to level up performance as much as possible and validate that this is creating user value. And only then kind of going down with the costs. And talking about this, like how do we level up performance? One is prompt engineering. If that doesn't work enough, then thinking maybe about fine-tuning these large language models as well. With the service API endpoints that we talked already about. And then we talk about the cost optimization part. There's of course then the not only the option of fine-tuning these large language models or say GPT-4 level, but then maybe going for like a 40 billion, 7 billion model like these Falcons and fine-tuning them. So there I wouldn't say it's so much on getting better than GPT-4, but maybe rather, okay, now we had this performance, we want to get kind of close and maybe close enough that we say, like for these kind of cost savings, this is actually for us still a good business case. Yeah, I mean, there you need, again, training examples, different ways how you can generate them. One is doing that more kind of offline, like in labeling processes. The other is, and that's the advantage if you start with these kind of prototyping from larger models, look at actually user logs, what do people ask, what was the answer, and then rather select from there, is that a good answer, yes, no. So then you have way more, say, realistic training data at the end.
And just on that point, because that is probably the biggest cost driver of training, right? On the labeling side, like it's, if you try to improve or fine tune it, it's really the labeling side, not the actual training part. Like, is there any way to just, you know, is it an automated way or a smart way that you've seen to reduce the cost of labeling?
Yes, like there are a lot of different approaches. So and I would say it's, yeah, there is some cost if you have like manual labeling, if you have, I don't know, experts sitting down and really doing that. But at this stage, it's not the, I wouldn't say it's the major cost. So if if we talk about like pre-training from scratch, or maybe the second phase that OpenAI is then afterwards applying, there you need like hundreds of thousands of labels, and this is very, very cost intense. If we talk now about fine-tuning such an already pre-trained LLM, this is rather in the hundreds or the thousands. So something you could often gather in a week, maybe two. This is not that much of work. Still, I mean, if you need more data, if you don't have these experts at your hand, there is ways to automate it. On the retriever side, for example, there's a very nice method called GPL, generative pseudo labeling, where you basically let models construct from your data questions, answers, and where you find this in documents. We use that quite a bit in our customers, and it's basically no cost. You can say, okay, create labels, train on it, gives you maybe 5%, 10% performance improvement, not crazy lifts, but decent. And you can do similar stuff on say the LLM side, the generative side.
Great, awesome. No, that's super helpful. Any last questions from the audience before we thank Malte?
I do have one. Just within the context of improving the accuracy of LLM outputs, I've understood that one method to do this is to set confidence thresholds to filter out or reject like outputs from the LLM that fall below a certain threshold. So I just wanted to know, in your experience, how effective do you think this method is for improving quality, like generally speaking?
Do you speak about like token probabilities?
Not quite, sort of like the confidence thresholds of the outputs. And I think there are a few different ways you can do that. I think looking at the probabilities as part of some of the parameters, at least with OpenAI, is one way to do it. Yeah. One thing that I've tried is to actually bake it into the prompt. So for each piece of output, to have the LLM itself provide a confidence score. Have you tried this, and how effective do you think it is my question.
We definitely tried it as well, and I think it's a also helpful technique. It's not a, I would say, silver bullet that solves it all, but it's more these like multiple small things that you can do that are helpful. With token probabilities, it helps to spot these hallucinations. So in many cases where, let's say, you have quite high probabilities for a token, and then there is one where it drops, for example, a numerical value is typical, or a year, that can be an indicator for hallucination. And on this confidence side, I think it depends a bit on the domain, how well these then model-produced confidence scores work, how well they are calibrated. If you feel, hey, okay, these values make sense, then yeah, it's perfectly makes perfect sense to use them as a post-filtering step then.
Makes sense. Thank you.
Fantastic. Thank you so much for your time, Malte. This has been very helpful.
Yeah, thanks for having me. Was a pleasure. It was really fun.
Yeah, that was really fun.
Should bring a lot of LLMs to production.
For sure. And I'll definitely ask more. If I have any more questions, I will definitely ask you 100%. Yeah.
Yeah, reach out. And the next time you're in Berlin, let me know.
I will, 100%. Great. Thanks, everyone, for joining as well. Have a great Friday.